Okay, AQA geography, living world, cold environments. So if you don't do cold environments, no use to you. And this is the north slope of Alaska, so the northern edge of Alaska, challenges and opportunities. What does the spec say? Development opportunities, so you've got to hit mineral extraction, oil, energy, HEP, fishing and tourism. And then you've got to look at the challenges. So that's the temperature, the inaccessibility, and the difficulty of putting in buildings and infrastructure. Quick location test. North Shore is up here on the Arctic, where they get the oil from, but they can't get the oil out of there because it's frozen for most of the year. So there's a pipeline that has to go down to the world famous Gulf of Alaska. And if you've watched ice road truckers and those kinds of things, you'll have seen the guys taking up all the big equipment up to there. While we're on the map, this is ANWR, ANWR. So this is an environmentally sensitive area. This is, in fact, as we'll talk about in a moment, a very, very important national park in the USA. So already we can see economic extraction, economic extractive industry, primary industry, oil, versus a very sensitive environment. Why is it a sensitive environment, or why are the challenges? Well, you can see over here. Temperatures in red, very, very low. Don't be fooled. These temperatures in winter go down to -25 and lower, and that's without the wind chill. And there aren't any trees around here because they can't grow, and therefore the wind does whip that up. So we've got a summer when just about we get above zero, and that creates its own problems when the frozen ground or permafrost melts, and that makes it very, very unstable, which means buildings and infrastructure can sink in and roads can sink in. So all of the challenges essentially stem from either the location of where the oil is and where it needs to come out, or the reaction of the environment and therefore anything you put on it to the melting of the permafrost. Lots of detail in there which you can read for yourself. But the key things, it's a wilderness area, it's extremely fragile due to very, very low levels of bioproductivity because of low levels of energy. So very low producing and therefore very simple. It's the closest you'll get to find food chains rather than food webs, because there aren't that many niches for things to take over. But there is great economic potential. The wilderness is for tourism, the oil is for oil extraction, the fish has been locally supporting the indigenous people in this area for a very long time, and now that fish is becoming more and more scarce around the world, we're beginning to see commercial fishing as well. So therefore we get the threats of exploitation and development versus environmental protection, and of course protecting the indigenous people, social protection. But we have the real big pull of a regional multiplier effect. Employment means increase in local taxes, which means increase in local government spending, which means an increase in improvements of infrastructure, which means improving social economic conditions for the area and allowing for even more development. So it's the balance. It's a classic geography balance between economic advancement, environmental protection, but cast in a place that is so fragile and sensitive that everything has to be done with care. Extreme cold, I've said some of these things, and obviously we've got limited working day, reduces the working day, and increases hazards. Just think about polar bears. So again, it's not just dark, it's dark and dangerous out there. Permafrost, I've mentioned before, you can read it for yourself. So adaptations that are required for these challenges. Houses have to be raised above ground, so there's no heat leakage, or if the ground, the permafrost moves, the house's foundations aren't bedded in the ground, so the whole thing moves. Put them on stilts, essentially. It also allows the air to move underneath, which if you like, cools the bottom of the house if it's going to be really warm, because it's got to be warm. And it means that the bottom of the house doesn't warm up the permafrost, leading to slumping. Build roads on gravel, because the gravel insulates the ground underneath. Oil pipelines on stilts. There's a famous Trans-Alaskan pipeline on its stilts. But of course, the problem is to move oil in these temperatures, you've got to warm the oil. So the oil is warm, but then because it's been warmed, they've got to keep it on insulating stilts. And it zigzags because this is also a tectonically active area. So they're trying to ensure that if the metal expands and contracts, or if there's a disturbance of the ground, there's flexibility in the design, rather than a straight line, where if anything happens, the whole thing cracks. They've actually, if you like, built some play into it. A little bit of movement is possible. Houses are triple glazed with insulation, of course. People wear multiple layers, of course. Remember, there's no such thing as bad weather. It's just in appropriate clothing. I like that one, probably Bear Grylls or somebody else. Geothermal power, believe it or not, is used because of the tectonic being a tectonic area, an active area. It's clear that you're going to have some kind of warm mantle stuff warming up just under the crust, and therefore they can use geothermal power. The underground pumps basically use water, but again, you can't let the warm water get into the permafrost because that will then lead to instability. Inaccessibility, it's miles away from anywhere. So in fact, you've got a limited population because there's very little economic activity, and they take advantage, of course, of that by having the ice roads. I'll keep mentioning it. Any disturbance of this ecosystem because of low levels of photosynthesis right at the beginning as the producers means that it's vulnerable. So small spills can have a very long-lasting effect. The opportunities, of course, are massive. Remember what the spec said, fishing. Alaskan natives have been fishing salmon for a long time, since the 17th century. This is essentially almost subsistence, almost wholly subsistence. And people use the fish, the oils from the fish, the bones, and they can trade the skins, for example, for cloth making, for making clothes. So it's a kind of subsistence economy. But then more recently, commercial fishermen. So the pollock fisheries of the Bering Straits, I'm sure you can remember that. 60,000 jobs, bringing in $6 billion. That's 250 million of tax. So it's not just oil. Energy I've mentioned before, geothermal is being used in places such as Chena Hot Springs, because we are on the Pacific Ring of Fire. And the Chena Hot Springs near Fairbanks provides all the local power. So at least you've got local power, which isn't coal burning. And then hydroelectricity, steep relief, lots of rivers, means you've got plentiful supplies of hydroelectricity. Can you remember one? How about Homer? You can remember Homer. So you've got a HEP station at Homer, which is generating electricity, even if it did cost so much, but not much compared to the amount of money raised from the oil. Tourism, Northern Lights, fishing, Yukon Quest, wilderness, etc., etc. Lots of tourism there because it's a wilderness area and it's very expansive. You can be there and not have to see people, buildings and things. But the big one, of course, is the mineral extraction. All of that's in your textbook. There's more detail about that, but I've dropped some things in there just to make sure you've got it. Keywords, infrastructure and mineral extraction. All that oil coming out is vital for the national and the regional economy. So that drives exploitation versus the environmental concerns. There's one question we know we've got. You can find some more videos on YouTube